My name is Jerry Quinn, and on behalf of the AFAA New England Board of Directors, thank you for joining us today. We have a great panel of industry experts lined up, and I'm looking forward to hearing their perspectives on emerging technologies, cloud, latest and greatest that they're seeing and hearing about out in the industry. As we get started, I'd like to thank our sponsors. We have Fire Command Systems, J&M Brown Company, Mammoth Fire Alarms, Norrell Service Company, Siemens Smart Infrastructure, Space Age Electronics, and TC Life Safety. Today's session will be recorded, so if you need to drop off, if you have colleagues who missed it, you can go to the AFAA New England site, and in the next couple of days we'll have it posted. We also, if you would, please mute yourself during the presentation. We have a few advanced questions that we'll be asking of the group as we get to the end. And but you can use the chat feature to enter some questions along the way as well. So without any further ado, we're going to get things started. John Houlihan, are you out there? All right. Well, we're going to just jump right in then. And Ben, I believe you're going to get things started for us.
That's right. So I'll share my screen and I'll crack on if that's okay.
Great. Thank you.
Share my screen. Tell me when you can see it.
We've got it, Ben.
Perfect. Okay, so first of all, thanks for having me along. My name is Ben Wolf. I'm the global leader for digitized maintenance and connected safety. So what I worry about on a daily basis is how can we at Notifier and at Honeywell ensure that what we're delivering for end user clients and also our network of installers, things which really improve their life immeasurably, things that really do cut through and make a difference in relation to how they serve customers, how we have an impact on a building, and especially looking at current circumstances and the way we currently operate. You may have noticed, but here in the UK, where I'm based, we've had this thing called COVID-19. You may have had it over there too. It's really impacted the way that we can use and interact with buildings in quite a dramatic way. So we really do need to shape ourselves for the future and understand what that means. And, I think we've all understood for a long time, if you go around any booths at any general kind of presentations or conferences, a lot of people are talking about the application of connected life safety, what that means, what that can deliver for a building. So, the way I'd start to look at the future and just boil that down kind of really quite, to quite simple terms. Increasingly, we're getting used to, connected technology around our buildings. How does it make us more efficient? How does it make us more effective? The fire industry is generally quite slow in terms of adopting new technology, and you'll find that often we've got a lot of things which remain unconnected. They're extremely reliant on time-consuming manual labour, especially around the testing processes and commissioning processes. So if I was to summarise what we want to achieve and what our vision looks like, it's about being connected, providing real-time data on events and performance, and automated, simpler, and more efficient to maintain. So, and what does this mean to a building owner? What does this mean to an installer? Well, it gives them reassurance. Has everything on my system been properly tested for full compliance? I've spoken to facilities managers, and it's a real kind of palpable sense of responsibility when you're looking after a building. You want to make sure it's done right. You want to make sure that you're compliant. You want to make sure that you're not stood up in front of a judge, saying, why did that go wrong and what have you done in order to kind of make sure the people in your building are safe. And people take that responsibility, rightly so, very, 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 very carefully. Hassle-free, technicians in and out your building quickly and efficiently. There are certain I was having a conversation today about the Burj Khalifa, tallest building in the world in that we look after in the United Arab Emirates. And they've got a team of 6 technicians who are there more or less full time doing all sorts of different work on that building. And it's very, very intrusive. You don't want that, especially in the post-pandemic world. You know, how can we make this quicker, more efficient and flexible? You know, we want to make sure that compliance are easy to reach, that they're easy to create, they're easy to access. You know, when you've got the fire marshal coming in, you don't want to be running around looking at lever arch files and, you know, pulling things off shelves. You want to make sure that you can get in, access it, and it gives everything that you need. So I've got a brief video because a lot of what we're discussing at the moment is stuff that we're actually launching and delivering today. So what you're going to see in this video is very much along the lines of you know, what we're able to produce today. And just before I do that, I'm going to stop sharing and share again to make sure I'm sharing audio. So forgive the little hiatus there, include computer sound. Just have a quick memory that needs to be done. So I'll press play on the video and I'll be quiet for a couple of minutes and let you see. And the technology seeing this isn't hypothetical, it's real. This is on the market at the moment.
In order to maintain any major facility, you need systems that are quicker to install, easier to use, less disruptive, and more compliant. We get it. That's why Notifier uses a new 3-pronged approach to fire and life safety. With detectors that can automatically test themselves, a control panel that's scalable, easy to use, and easy on the eyes, and a cloud-based software that guarantees compliance. Notifier's new solutions are changing the way fire and life safety systems are managed, operated, and maintained. At the forefront of innovation, Notifier's self-test series of detectors are the first UL-approved detectors that can be tested automatically. This technology revolutionizes the test and inspect process, reducing the time it takes to conduct a proper test from days and weeks to hours and minutes. With Notifier's self-testing detectors, technicians don't need full access to difficult spaces like elevator shafts, private rooms, and high ceilings. Instead, they can get in and out quickly by conducting a short visual inspection, reducing disruptions to your occupied spaces. Notifier's self-test detectors are also much safer, as the system remains operational during the test, raising an alarm if a real fire is detected. When coupled with Honeywell's Connected Life Safety Services, CLSS, this process is optimized even further by generating digital compliance reports at the touch of a button, anytime, anywhere. Gone are the days of manually transcribing reports and week-long delays in delivering results to local authorities. Beyond tests and inspections, CLSS allows you to stay on top of maintenance schedules and react quickly to incidents by providing a remote view of your facilities. This remote view is also available to your technicians, enabling them to diagnose problems before they arrive, limiting their time spent on site, reducing costs, and improving first-time fix rates. And last but certainly not least, the Notifier Inspire series takes center stage as the next generation of connected life safety systems. This game-changing panel is aesthetically pleasing, user-friendly, and perhaps most importantly, unlocks access to self-testing detection technology. Notifier Inspire is also highly flexible and scalable, growing with your needs and minimizing equipment changes and costs. We know you have more to worry about than your fire systems. That's why we've created solutions that together deliver real-time protection, are fully compliant, enable efficient monitoring, and deliver timely reporting with unmatched scalability. It's all possible with Notifier Self-Test, Notifier Inspire, and Honeywell's Connected Life Safety Services, CLSS.
So thanks for being patient and sharing with that video, but hopefully that made a lot more sense in terms of explaining what connected services can be and should be. And you know what Honeywell and Notifier are able to offer today in the market. And you know, really, you know, does that mean? What is what does this mean for a building owner? What does this mean for an installer? Well, we've done some understanding of that. We've done some time and motion studies where we actually looked at the manual process of testing a system and ran it real time alongside of the time it took to do exactly the same building, using the three products that we have in market today. And we found that we actually reduced the time it took to complete the inspection by around about 84%. So, we really are, it's not something that we've done in terms of, kind of new technology and trying to realize the vision of what connected life safety should be. We're not playing around the edges. We've got something which we believe is quite a step change in the market, and really kind of helps, ensure that we're not, being, we're a lot easier to deal with. Looking from an end user's perspective, they're often their janitor staff are tied up for days, no end of time in terms of supporting technicians to get around the whole building. That can be streamlined and done a lot easier, and it's safer as well. A detector can't be missed. That one that's in the void, the one that's in the lift shaft, the one that's in the locked room. It means that we're testing all of these things, and that we've got this kind of visual inspection process to make sure that we're kind of ensuring that technician is within visual inspection range, that device has seen it. And also, one thing that the video didn't mention as well as doing a functional test of the device as in can I see smoke, it's also part of the process we can pick up anti-masking, so it can tell if there is anything covered on it. We've done numerous tests from bathroom paper to shower caps to plastic bags, and of course our old favourite dust caps that remain on there after installation, or if somebody's done a job decorating or renovating a room and left it on. We can pick all that up in the annual inspection. So really that, I wanted to kind of keep it brief and simple, and hopefully that kind of summarises our thinking in Honeywell and Notifier, and gives you a kind of flavour about what connected safety means, what the vision is, and we're looking at building upon this as well, but also kind of how we're able to realise a lot of what our vision is today and in market. So these things are available, and we've got some very strong early interest on it. So that's me in a nutshell. So thank you very much for your time, and kind of happy to kind of take any questions as we move forward on it. So thank you for your time.
Thank you, Ben. That was great. Well done. And folks, use chat if you want to have questions for Ben. We'll get to those at the end of the meeting. So please feel free to enter those there, and then we're going to turn it over to Jeff.
Hi, everyone. Let me just bring up my slide. Hold on a second. There we go. Okay. Hi, everyone. Jeff Klein. I'm with Potter Electric Signal, responsible for our fire safety and ERCS divisions. Before I get into my slides, I wanted to share an interesting experience I had some years ago related to connectivity and cloud. I had the privilege of introducing an early connected product for mission critical applications. And I'll never forget it. I was talking to one of our channel partners, and they said, "Oh, did you hear about the disaster that's happening?" And I thought, oh my goodness, being a life safety person, what first comes to mind is it didn't go into alarm, didn't detect an emergency, didn't notify anyone, all of those bad possible things that we worry about. And it turned out that the feedback was no, the life safety part of it worked perfectly. It was the connectivity that was a problem. And at that point, I knew there was a change afoot in terms of what was happening in the industry. So what I'd like to do is just share how we think about taking advantage of connectivity and cloud, and sharing that with everybody as we think about it at Potter. So just showing how we think about it. We look at it as a few different parts and pieces. So the first part is the physical layer, which is what lives actually on site and what we refer to as on-prem, which is physically located in the space that's being protected. And then we go to a hybrid, which is where we're taking advantage of cloud connectivity. And in that case, that middle ground is where we can take advantage of data that gets pushed to the cloud by the on-prem devices, and then you can use web-connected computers or applications. And then the last part is the hosted part, which is purely living in the cloud. So one of the things to be clear from our perspective that we would not want to see happen, and perhaps it does, and you know, we could talk about how we become extinct, but we do not believe that the right answer at some point is a fully cloud connected fire alarm system. Admittedly, we worry a bit about latency that might come into the system. So, you know, if a event is detected and then it has to communicate to the cloud has to make a decision, and then finally a notification happens, you know, we would worry about whether that would happen in time in a life safety emergency. Because first and foremost, we definitely think about the products that we provide are for life safety purposes. And so we believe, and I'll talk more about the benefits related to this combination of on-prem, hybrid, and hosted, and taking advantage of connectivity and cloud as much as possible. So on the on-prem side, very straightforward. So there's networking of panels across that whole campus. That's where you tie in the edge inputs to the edge outputs campus-wide. So if one thing happens in one part of the campus and you want that tied in so that something happens in another part of the campus, that's on-prem. That's taking advantage of an IP network. Those are connected. There's good speed of action that's happening across. There's also good addressability. It's a way that you can do mass notification where you want to connect other disparate things. So that is the benefit of a networked on-prem side. And then I would say the way we think about it is we would call it cloud ready, which means that all of the data is connected, and if desired, we could push that information off into the cloud. Note that this is separate and distinct from a tie-in to a central station for monitoring purposes. So what I'm talking about is the connectivity and cloud associated with other services, not for notifying a central station. That is separate and distinct and tantamount, and you know, has to happen and follow all of those safety protocols, et cetera. So that's what networked on-prem. Hybrid, which is where there's a lot more opportunity, is where you can have this mobile and web-based access. And essentially, we're taking that information that is living on-prem and we're moving that data up to a cloud file location that can now be accessed by mobile or web-based equipment. That enables a technician, for example, similar to what was presented earlier, if a technician wants to single-handedly test a building, they can introduce activities that happen utilizing their phone or tablet computer to initiate a process that then reacts on site on-prem, and then data interchange back to that device to confirm that it's happened. We can also see notification of events that happen. So an event happens on-prem, pushes that information up into the cloud, which is then tied to a mobile device. you can get system status. That can be in real time. That could be, a once a day upload, and you can take advantage of that connection. The other thing that we like about it is it's an area where you can store and download programming. So one of the benefits of having configurations stored in the cloud is, what happens if, for example, a mistake was made in a configuration and you want to go back to what did it used to be. You should be able to take advantage of that. It's already there. It's set up for that application. And, with a couple of steps, you can get that downloaded back into the panel so that it can be up and running while you're figuring out what you did wrong. We do support panel control via mobile access. That's mostly around testing and maintenance. One of the things that we do not support, and it's actually in a later slide, but it's worth mentioning, is we don't support the opportunity or ability to acknowledge or reset a panel when you're not on premise. So I jokingly tell people, hey, if someone has gone out and had a good time and they're sleeping it off in Europe, I don't want them getting notified on their phone and deciding to acknowledge an alarm of an emergency when they're not on site. So definitely on-prem is where, if there's an alarm that needs to be acknowledged or a system reset, we feel very strongly with that. That's in concert with the codes, and we obviously support that. But there's nothing that says you couldn't get information up into the cloud and then take advantage of that with your mobile device. And then the last part is taking advantage of hosted. So if you think about if there were to be a wall, if you will, that is on the other side of the cloud that's tied just to our system, so call it a ecosystem for that campus, we would support, and we do, having a data interchange between the cloud and other services. And what does that do for you? Well, that's a place where more analytics can happen, so others can access that data in the cloud. They can use that for understanding trends, et cetera, that are happening with a particular system, or better yet, with systems in a general area. For example, this happened once in Chicago where there was an environmental situation that happened that caused many carbon monoxide detectors to go into alarm. Well, it'd be good if you had all of that data and you could look at it across all the different systems and understand that this was an environmental condition that affected all of those systems. But that lives in that separate cloud where the data is resident and is not having any impact on what I call that walled off ecosystem, which stays pure and protected from the outside world. It's also a place where you can store events. Memory is pretty cheap when you're in the cloud, so you can store events, you can store prior configurations. That's a place where design drawing files could be stored associated with an install. Imagine a world where the fire safety department is coming to an emergency and they were to have an application on their computer equipment where they can tap into that hosted information, and before they get there, they can know the different configuration that resides in that building, places where there are barriers, places where there are different parts of the building that they need to be aware of, storage of chemicals and things like that. And then lastly, this is a place where we would connect to other services such as testing and maintenance companies that provide those reports. So we do make that distinction and attempt to keep that kind of walled off. And then lastly, this is my last slide. Just where do we want to go from here? We do want to continue maintaining that on-prem for those standard life safety functions. We feel very strongly, as I said, about we do not support unattended acknowledge or reset of a system. We like leveraging that hybrid approach where you're taking advantage of mobile and connected and having a connection between the cloud virtual world with that physical world that's on-prem. We do support and would love to see an advancement where you can do remote system configurations. We do understand there is some trepidation around, well, someone should be on site to acknowledge that an upload has happened. I get that, and we get that. But we also think there's probably some technical ways with some proper handshakes that would enable that. And I think that could be perfectly okay. And then lastly, taking advantage of the cloud and all of its storage capabilities and analytics and the rich data that exists that could be used by other services. I talked about for testing and maintenance. I talked about for the fire service and first responders. So we do want to take advantage of that. And then lastly, in terms of future state, we're kind of living betwixt and between in terms of putting fire alarm systems onto the actual corporate network. And I know there's concerns and resistance around that. The case for it is that the IT department is living and monitoring that on-prem IT network all the time because it's vital to company functions. And actually, in a lot of cases, it's actually very hard to get the fire system onto that corporate network. But if it did, this is a case where it's being cared for, fed. It has very robust security. So we do think in the future that'll be more possible and more likely. And we definitely support that trend. I mentioned how we'd like to see remote programming with the proper controls in place. And then lastly, we think this is a way that this on-prem system can get exercised more regularly via mobile and web applications, and even taking it further to enabling the end user to exercise the system. The reason we advocate for that is then there's a familiarity with the system so that when there actually is an emergency, they are ready to use that system and know how it works. So that's it for me. And I'll stop sharing and turn it over to the next presenter. Thanks for listening and look forward to answering some questions in the Q&A.
Thank you, Jeff. Appreciate it. And we're going to go over to Lily Dillon now. All yours, Lily.
I should unmute. Can you see my screen?
Yes, we can.
All right, perfect. Hi, everyone. My name is Lily Dillon, and I'm the product manager for digitalization of fire safety at Siemens. And what I want to share with you was a little bit taking beyond, cloud and IoT, and share with you how cloud connectivity and fire systems are converging into smart buildings, and kind of where the future of cloud connectivity is going, and how cloud-enabled portfolios that manufacturers are developing work together with smart buildings. And so, talking about cloud and IoT, and two earlier presenters talked about it as well. We look at buildings today, we find, they're more and more connected than ever before through smartphones, general user accessibility, tablets, computers, remotely. And we're also finding that as a part of this connectivity, smart buildings also. And so with smart buildings and smart cities, the need for fire panels being connected also to the cloud is becoming more important due to the benefits that you can get that we've shared a little bit, and I'll also share during my presentation. And just a little bit just of definitions, just for those who might be new to kind of technology in this way. We're talking about cloud. What is the cloud? It's really all the things you can connect and access remotely over the internet. When something's on the cloud, it's stored on the internet servers and not necessarily on your computer hard drive. And with IoT being the Internet of Things, the system consists of a network of physical sensors, devices, which I'll talk about, in my subsequent slides. These are things that talk to the cloud through some kind of connectivity. And once the data gets to the cloud, software processes it, and then it decides to perform an action on it, whether it's sending a notification through a phone, or telling you something is dirty, the software processes it and then decides to perform an action, and maybe even automatically adjusting devices without the need for a user to do it manually, just trying to make things more efficient. And today what we see is that IoT has evolved a lot due to the converging of multiple technologies. So, the future of this, and it's already happening today, is like real-time analytics, machine learning, various other technologies. And you probably have heard already of the concept of smart home, which is like devices like appliances, lighting fixtures, thermostats, and security cameras that are all connected. And so this is now evolving into also smart buildings, which consists of devices and sensors used to keep a building safe, comfortable, efficient. And then remote access, Jeff talked a lot about that, about what we should and shouldn't do. So really, it's the ability for an authorized person or someone who's allowed to, remotely view what's happening at a site, in our case, a fire panel, from a geographical distance through a network connection, through the building's network connection, a cellular connection, to be able to see what's happening on the site. So you can be, you can see what's happening without physically being next to it and taking advantage of that. And the reason, many of us and manufacturers are moving towards the cloud and IoT is due to a couple of, many pain points that we've seen. A couple here are, for example, service companies have limited visibility on the systems they maintain, and this results in high cost for manpower, travel time, not knowing what's happening right away at the site, going back and forth to maintain a building. And at the same time, owners, facility managers, can't easily centralize responsibilities because their responsibilities are also across multiple systems in the building, not just fire system. And so, kind of results in multiple silos, and sometimes decisions can be difficult just due to a lack of transparency of what's going on in fire systems and other systems. But now with, more and more technology, with more sensors, connected mobile devices, and cheaper technology as well, we can help these personas, building owners, facility managers, service providers, make decisions, respond better to issues, more information at hand to know what's going on to their site in advance as a basic offering, and then in the future, adapt to its environment with the new, algorithms that are coming out. And I'll talk about that as well a little bit. So in terms of, smart building, IoT solution is really a data-rich platform. So it uses smart sensors to collect and analyze data while adapting and controlling the environment around you. And that's pretty much what's happening already with the other sensors around there. Not so much with fires yet, but we can see that it converging with what's already happening in like thermostats and lighting fixtures that's already going on. So, for example, the network of smart sensors can help a building automatically and intelligently respond to changes in the building, like occupancy, from dimming lights when the conference room empties to dialing up the HVAC system when a room is full. You can rely on these sensors to optimize the experience in the building. And with fire, as part of the IoT offering, we can also, first remotely view and advise owners what's happening, be really efficient with the building. But in the future, we can leverage this fire data to be more efficient, like detecting a fire, reacting accordingly, analyzing sensor information, like how dirty is a detector? Does it look like it's going to go bad? Possibilities are really endless with this. And then we see with smart buildings are a lot more people-centric spaces, and that people who are in the buildings are expecting higher performance digital applications to enhance the experience, and then achieve sustainability, wellness goals. Air should be good. We should all be safe, and focus on individual control over the space around them so that they can be comfortable and less disruptions, higher building uptime. And coming back to the journey towards smart buildings. So everything in the building industry, as we knew it for a long time, started with the traditional building, which is the building with no connectivity to the systems installed from the outside perspective. It's in some ways it could be inflexible, because you don't really know what's happening unless you're in the building, and installed products could become commodities. It's a little bit, of an expense factor when you're servicing it. And then with the automated buildings, it was really like the moment where the building management stations came into play, and it really allowed us to integrate many different disciplines into the buildings. And this included, for example, the lighting, security, which has been connected for a long time, and fire detections, elevators, and so on. And today we are in the era of smart buildings, IoT, cloud connectivity. And at Siemens, we define this as a building that's much more than the passiveness of yesterday, but rather a building actively contributes to the success of its occupancy owners and continuously interacts, learns, and adapts using the data from the smart sensors in the building. And another milestone is also building twin, which we're kind of coming to terms with what building twin is. It's really what we see it as is all the information about the building itself, including the ability to analyze it. And really, like, this is how we are seeing kind of the future of towards the smart buildings and how cloud and fire is kind of integrating with it. And then we've already seen the next level of buildings kind of come into play, like what's coming up beyond, smart self-adapting buildings, how we're leveraging the data from the sensors, from the detectors, from the devices to make it intelligent, to make sure we're protected as much as possible. And then with regards to smart buildings, cloud portfolio, like Siemens has a solution pretty much for every aspect of a building. So it offers connected devices, and a cloud application platform across our disciplines, including fire panels as well, being connected to the cloud. So we have smart devices. They're enabling products to allow a building to capture and collect data. And here you can see also security cameras, management stations that have been connected for years, and we're expanding to smart thermostats, intelligent valves, and fire panels to the IoT devices here. And then the IoT devices or cloud enabled devices connected, they're integrated into a cloud platform. Whether it's using Amazon Web Services or Microsoft Azure, really these trusted, secure platforms that provide the cloud services. And integrating its technology, what we would want to see is it should be simple. This could look like really complicated. Cloud could be a really scary term, but ideally with cloud, it should be plug and play. It should be simple to connect. We want to make it efficient to the person who's using it in the end. And then you get analytics platform where you get the intelligence goes into the cloud, and then the visualization of the data from the devices is really part of the cloud applications. Cloud, whether it's on a mobile phone or on a laptop, just being able to remotely see what's happening at your building in the first aspect, and then adjusting based on the information that's available using analytics and also providing it in a secure way. And then with IoT sensor data, at the same time, it's being used to adapt building space, making it comfortable for tenants, energy efficient. So no matter, what the different disciplines are, fire, we wanted to, have that part also included as part of the whole smart buildings cloud portfolio to take advantage of that efficiency that's already kind of been established in the other disciplines. And then, just 2 slides to go here. So from the Siemens perspective, all the manufacturers are, starting to have cloud applications. And for us, we have this cloud connection to our fire protection system as well. And it's really helping our service providers digitalize their service and maintenance offerings, and also allow end customers also to see what's happening on their buildings, should they not be right next to it, or if they have like a big campus. It's really increasing the efficiency overall for all the users, reducing time and travel costs to be able to maintain their system. And this is just, right now, the powerful highlights that it offers. And so really enhancing the safety of a building by providing remote monitoring from anywhere, anytime, and leveraging it for monitoring, testing, remotely gathering logs, trying to make the experience efficient, and also the remote troubleshooting also as quick as possible, because the safety of the occupants are also very important. And to conclude, there's a lot of benefits I've mentioned. And so, just in terms of smart buildings, where the future is going, smart buildings overall enhances the occupants' safety, well-being through continuous connectivity. It improves the productivity of the building's tenants. It's leveraging technology. It's got actionable information, so the environment's productive and attractive for them to want to keep working there. And, smart buildings understands its environment. It interacts, it learns, it adapts. And by adapting, it's making it more efficient, and then resulting in a higher return on investment too. And then at the same time, with higher return on investment, on reducing costs for a building operator, by knowing what's happening remotely, by being able to get someone from a service technician, knowing exactly what's happening, being able to remotely help the person, on the phone or something, by knowing what's happening, it's really making it more efficient. For now and also in the future. So, where we see it is it's not just a single system anymore, or a series of siloed system, and really, the focus is on the users of the building, the customers themselves, and making it safe, productive, and a better experience. So thank you for this time. I'll pass it over to the next presenter.
All right, thank you, Lily. And as with everybody, if you could hold your questions for the end, and we'll be taking them there. I'm not sure the chat's working, so if it's not, we'll just, people can raise their hands and we'll just go in sequence once all the presenters are done. So Roger, you're up next.
All right. Hello, everyone. Let me go ahead and I'll share my screen as well. All right, looking at the names that are out there, I see a lot of familiar people, and I just thought I'd take a little bit of time and go through kind of some of the things that I'm seeing. I'm fellow and vice president of industry relations at Johnson Controls, and as we look at Internet of Things, Internet of Life Safety things, what's going on with NEMA, some technology, and then finish it up with POE. So I got a few slides to go through, and I'll try and make it quick like my counterparts did before me. When we talk about Internet of Things, it really means different things to different people, and there's not one clear definition that we use. When you look at Google, a proposed development of Internet in which objects have network connectivity, allowing them to send and receive data. That's probably the high level of what Internet of Things means. When we get into kind of our world, it's sensors and actuators embedded in physical objects, and they're linked through wired or wireless networks. You got Wikipedia, you got different things on how Internet of Things is starting to come about with vehicles and buildings and other things.
So,
Hey, Roger.
Excuse me.
Sure.
You're not, I don't know if you mean to be presenting, but you're not. We're not seeing your screen at the moment.
Oh.
We saw it briefly.
Sorry about that. Let me go back and see what's going on here. Sorry, I'm glad you said something.
Yeah,
I was going really good too.
oh, you're going great.
How about now?
We have it again.
Okay, and I'm going to go into presentation mode. Still see it there?
Yes.
Okay, good. So as we look at Internet of Things, we a lot's changed in recent years. When you look at when the iPhone came about, it wasn't until 2007. It wasn't that long ago when things really started to change our connectivity and how we're able to send and receive information one to another. And Internet of Things, when it comes to architecture, cybersecurity, we've kind of all been talking about that. And then now we're starting as a world talking about clean power and electrical safety information and importance of enforcement and regulations that come into play. The AFAA breakfast that was this morning, you had a great speaker there talking about regulation and cybersecurity and physical security. And as our buildings are connecting together, more and more data is coming about, these microgrids and direct current in buildings. I'm going to focus on that here in a couple of slides. So currently, I'm the chair of NEMA's life safety section. It used to be called 3SB, now it's called BSSB. And they have a NEMA COM test, a test for owners, operators to kind of prove out what you're developing. Phase A has been completed. They described the testing and guidance on how you do that. And Phase B is ongoing. Equipment that's being tested in the National Renewable Energy Laboratory, Energy Systems Integration Facility. So a lot of this work for us as manufacturers to prove things out to owners and the government to say, yes, this is something that's working, is being kind of spearheaded by NEMA. And NEMA has an Internet of Things handbook that I think is very good. It's kind of a Wikipedia style of a document. NEMA documents, a lot of them are free to download at no charge, and you go to the NEMA's website. But I just wanted to let everybody know about that, what's out there. And the strategy initiative that NEMA is working on for manufacturers. So it's a guideline for us as the National Electrical Manufacturers Association on how we follow up during all the stages of the supply chain to minimize software bugs or malwares or other things that might affect a product, whether it's manufacturing, delivering the product, the operation of the product, who's able to install it, and the end of life. And I have a link here, and I don't know if these slides will be available, but if you just go to NEMA's website, a lot of this stuff is there. And it's an interesting read, and there's a lot of task groups and committees that NEMA is working on to help with this. So talk about technology for a minute. And you've heard it from a lot of other people already. What we're hearing, voice of the customer, and that was a direct ramification of creating Class N, is because of what customers were asking. They were saying, look, you people in NFPA 72, you created a new chapter and a new way for us to do other things than fire alarm, mass notification, area of refuge, all these other things that we can now do. Well, do we have to just use fire alarm stuff, if you will, or can it be other things that meet a reliability assurance level, and can we call them something different? And that's where Class N came from. When we talk about the now, today we're able to use UL listed network switches. We have UL 864 hubs, routers, switches that we can use that are strictly for fire alarm use. The industry has TCP IP bridges to go from the fire alarm system, if you will, to the public LAN or infrastructure, fiber that we've all used, BACnet's out there, and mass notification, area of refuge are coming into play in more and more places. But when we talk about life safety, we have the near and we have the far, and there's some things that we're hearing at Johnson Controls anyway, and we're working with a very, very large manufacturing entity who wants to prove this out. And one of the things that is coming up, and I thought it would be interesting to talk about today in my few minutes, is power distribution. And you might first think of that as, well, what's the big deal? It's power distribution. You run AC lines through the building, plug into it, have a nice day. Well, what's going on is putting in DC power into a facility and having everything in the building run off of that DC power. But not only run off of that, communicate off of that. Think of it almost like power over Ethernet, PoE, but on a much grandiose scale. So there is a Marriott hotel outside of Dallas, Texas, who is actually running this DC power system and has all of the systems in the building running on this: the lighting, the HVAC, the elevator, fire alarm, etc. And when I look at this, they have these zone boxes, these power converter boxes. Think of it in a really crude way, like when you're able to take your iPhone and just lay it on a charging mat and it's able to start charging. That's what these boxes are sort of kind of doing. They're sending out high pulse with DC power, and because they're able to sense if the power is being interrupted by the frequency that they're using, they're able to shut it off faster. So they're saying it's safer, and we're able to also communicate over this. And why use DC power? And this, again, I had to go out and find out why they want to do this. They're looking at more flexible and simple design. It's one footprint. There's not all these AC wall warts that are out there. Improved energy efficiency, lower installation costs, and lower capital costs. That's more than half of the reasoning why companies are doing this. And we're hearing from the customers, and we're working with a large manufacturer, as I said now, where they're building a 3-story building just to prove out this technology. So they've invited the lighting, the fire alarm, the security, everybody together. And we actually have a lot of Johnson Controls equipment running on this DC system where it has no AC power coming into the building, and using their converters, and we're talking to one another. We're having fire alarm communicate to security, to HVAC, etc., but all through this DC powered network, not BACnet or anything else. It's really kind of interesting whether this works or not, or this becomes mainstream or not. It's an interesting thing that I thought I would bring up and just let people be aware of what's out there. For signaling line circuits today, we all have fire alarm control units tied to data gathering units that are out there, transponders, whatever you want to call them, and it's our dedicated life safety network. So now we have Class N short for network, if you will, as an Ethernet network. And I like to make the comparison to people about cell phone technology. it wasn't until 2007 that the iPhone came out. And before that, everything, it was a cell phone that I had, and everything about that device was the phone. And yes, I could start to do a little bit of text messaging very crudely, maybe a little bit of email very crudely. But when the iPhone came out, it changed the game. Now I have all these apps to do pictures, cameras, videos, go on the internet. And I have a module or an app that is a phone. So it's gone from being a phone really to being a communication device that allows you to do phone calls. And I say all of that because that's what happened in the fire alarm world. When you go back for, in the simplex days anyway, back in the 1980s, 1970s, I had a 2001, it was a fire alarm system. That's what it did. It was hardwired, smoke detectors, pull stations, horn strobes, have a nice day. Today I have a fire alarm system that's really more of a life safety system. It's communicating to all kinds of things. It's doing area of refuge, fire alarm, mass notification, and many, many other things, gas detection. And it's really flipped around that, oh yeah, it still does fire alarm, but it's really a life safety system. And we're seeing that trend happening in all of our codes today. So when you look at the now, we have Ethernet switches as an industry that are listed for fire alarm, UL 864, or if you're up in Canada, S527. They're fully supervised, life safety, what have you. When you look at power over Ethernet, it's a little bit of a misnomer of power over Ethernet. It's really power over Ethernet cables. So I have a switch, a router, a hub, and I can plug in my 4-pair 8-pin connector, RJ45, into the wall, but I'm using some pairs to communicate on and some pairs to power the device on. So it's not using one pair that does everything, but it's one cable that does everything. And this starts to get interesting in the NEC. I sit on CMP Code Making Panel 16, which deals with 840, Article 840, 760, and a bunch of others. And we're talking about PoE. And now people have these gobs of Cat5, Cat6 cable all through their building, and they're starting to use them now instead of just tying to a computer piece of equipment, but to start to run power over it. So now you've got 24 gauge, 26 gauge wire out there, and they're pumping maybe 60 watts of power over one pair. Sometimes they're doubling the pairs up to get more power out of it. So now you've created where this big bundle of cables is going through a building for maybe the past few decades. Now these cables have become little heaters, and they're possibly a life safety hazard where more and more power is getting pumped through them. Hospitals now want to take the television, mount it on the wall, plug it into an Ethernet port, no AC power, run the TV, give you a box to control it, laying in the bed, and now I can watch videos or click things off, training that I have to have before I can get discharged, but everything is running over PoE. You're starting to see it more and more with the IV pumps and other things within hospitals. Definitely in schools, they've been doing this for years. So we need to be very, very careful when people say, yeah, I already have Cat5 installed throughout my facility. Let's just go ahead and use that. Well, it might not be just as easy to do as just doing that. So on 725, we talk about power and data. As a side note, when you look at the NEC, there's a big debate on who owns PoE in the code arena. Is PoE power or is PoE communication? And you keep seeing this volleyball going across the net to, well, that's comms, well, that's power. And my opinion, there needs to become a PoE article within the NEC that really absorbs all of this and takes it in, rather than pinging it all over the place between different articles. But that's what's happening today and where we are. And I know I don't have a whole lot of time. So IP based on the life safety of the now. We're all doing this, right? We have fire alarm control units that are networked together. It's UL listed, agency listed, if you will, and we're able to communicate to everything. Maybe offer an app or something to a device. But the near, what customers are really starting to drive for is, I want more and more of this stuff to be able to go to my tablet, my phone, or offsite computer or what have you. And I don't want to be tied down to your way of networking. I want to use off-the-shelf networking stuff that's out there. You know, and they're requesting this from us today. They want us as manufacturers to start to do this. Everybody has really been, I'll say, overwhelmed with the Alexa devices or the Google Home devices or whatever is out there. And as they're getting more and more comfortable with that and interfacing with it, people are asking us today, well, when can I just say, hey, Alexa, what's the status of my fire alarm system? And then for the fire alarm to say, you have one smoke detector that's almost dirty, or you're due for maintenance of your annual inspection in 2 months. Would you like me to schedule that for you now? Those are the things that we're thinking of or trying to get ready for. And you see that in the code. So in NFPA 72 in 2019, language was added for a building system information unit. This allows us for the first time to use not fire alarm UL listed 864 hardware, but off the shelf hardware. And I don't want to turn this into a BSIU seminar, but this I think is a huge advancement for the life safety world to allow us to offer a more economical way for end users to have the graphical interfaces that they've so much wanted and desired without the humongous price tag that I've been forced to deal with when it comes to the computer being UL 864 listed along with the software. So this might be another seminar for another day, but BSIU is in 2019, and you're only going to see this expanded upon as it goes forward. And then we talk about this at the protected premises and how it can start to integrate with other things, whether it's your HVAC system, security system, or what have you. But there are hurdles, stopping points, checkpoints, whatever you want to call it, that we don't want to compromise life safety. You know, as we often say, just because you can do something doesn't mean you should do something. And just because you can do something doesn't mean we need to lower the quality or the reliability of the life safety systems. So under this Unified Building Management System, the FAR, and I'm saying the FAR probably within the next decade, this is what people are talking about when they're coming to us at the very high level, these large manufacturing, pharmaceutical facilities, et cetera. I want to put everything on the backbone. I want to tie it all together. And the way that the infrastructure that these facilities are putting in, sometimes, not all the time, sometimes it's better, more reliable than our fire alarm networks. And some of you are saying, well, wait a minute, that can't be. Think about it. These people that I'm working with, they'll tell me, because I've done the same argument with them. I'll say, hey, if I put this on your network, there's a problem with, well, what if a port goes down? What if you're doing a software upgrade? What if somebody just disconnects something? And these people in the IT field, they kind of laugh at us and they say, you don't get it. By the time a port is unplugged, a port fails, I know about it. I have somebody responding. I'm replacing that equipment far before you guys even know that it happened, and you're able to get a service tech into our facility. And it really, in the right circumstances, and that's where you start to see risk analysis and does it make sense for this facility? I am not saying to do this in a Marriott or a Home Depot or something like that, but in these large pharmaceutical manufacturing facilities, it makes a whole lot of sense to sit back and think about that. You know, I can remember back in the 1980s when AT&T was running around saying everything was going to be on one pair of wires. Your thermostat, your smoke detectors, your lights for your system in your facilities, all were going to be on a pair of wires. They had the right idea. They were just a few decades too soon with it. So the next thing's going to be, well, why can't I put my fire alarm on that? Why does my fire alarm even have to be wired? Why couldn't my fire alarm be 5G? 5G is coming on strong. Elon Musk is looking to put satellites or drones or gliders that anywhere in the world you'll be able to have internet access. And why couldn't we use 5G embedded into our smoke detectors, peripheral devices, kind of do the same thing inside of a building? And that's being explored. We're looking at doing that. And customers are asking us for that. Why do I have to put in dedicated copper just for you guys when there are other ways that we might be able to do this? So a little bit different, you know, thinking what's going on out there in my world, but I just thought I'd kind of share a little bit. So I hope that was worth it.
Yeah, very much so, Roger. Thank you. It's a lot to think about there.
Yeah.
So John, we are on to you. So thank you, Roger.
Very good. And just confirm you can see the screen.
We can.
Great. Well, good afternoon, everyone. Like the other panelists, it's great to be able to be here with you today and talk about these things. I think you've heard a lot around the general nature of connectivity in our space, and so I thought it made sense to do a little bit of a deeper dive around cybersecurity. It sounds like that may have happened a bit this morning at the breakfast, and by no means I am not a cybersecurity expert, but I think if we can highlight a few relevant topics, it'll be worth the conversation. And given the recent news of Colonial and JBS, and there was even an article in I think the Washington Post this weekend about ransomware in schools and medical facilities. It's certainly a relevant topic as ever there has been. So, and before I got started, I think everyone is familiar with Edwards, but we are now part of Carrier. It's our most recent parent company, and we're only a year in as a publicly traded company. So I wanted just to do a quick connection there. If you see the Carrier over on the slides, you know where it's coming from. But Carrier is a business of HVAC, refrigeration, fire, and security. In North America, you would know us through the Edwards and the Kidde brands for the fire alarm system. So we fit within the fire and security division of Carrier overall. Okay, so let's get into the topic here at hand. I'm going to try to walk through a bit of a progression here, similar to what Roger just did in terms of where we're coming from, where we are now, and where we're headed going in the future from a cybersecurity perspective. And I think most everyone knows, the most basic way of keeping the system secure is through a physical access control mechanism, right? Making sure the control rooms are locked and secured and only the right people have access, making sure the panels and enunciators and repeaters have the locks locked and hopefully the keys aren't left in them permanently. But just keeping the right people to have access to the system was the first means of security on a fire alarm system. But in terms of the networking perspective, obviously traditionally we had our proprietary networks, creating this air gap, very separated as we've heard in the other presentations from the IT or other building networks. And, I think everyone's familiar with this. You had to keep this separation between the two networks. In today's nomenclature, we might call this social distancing, but that's probably another topic here for a different day. And even though we had these proprietary networks in the air gap, historically even there have been some external connections and exposure points. Things like central station communications, other building system connections that we talked about, building automation and other devices that you've heard in some of the other presentations. And these obviously create some opportunity for exposure to outside attacks. Another way to think about this is even from the traditional network design where in a traditional token ring network, you may have had something like a centralized audio control, where you have your messages and your databases stored centrally, consolidated down, and broadcast through the network, and that can create a potential single point of failure. Where historically, what we talk about is if there was a fire or something that took out one of your nodes, you might lose that voice capability downstream of that node. But as we get into this more connected world, what would that mean in terms of things like a man-in-the-middle attack, where an incursion could come in between two nodes and potentially take down the rest of that system? Do you lose really critical notification and enunciation capabilities of your system? So even thinking about just the way the networks are designed is becoming more and more important in this overall discussion. Roger just talked a lot about this, so I don't want to go too deep into this, but, with the advent of Class N, as you mentioned back in, getting the code in 2016, and the concept of having shared pathways to allow these systems to work on the same networking infrastructure, it's out there. As you said, there are end customers looking for this. There are ways to handle it. The code is helping us get through there, and that's just increasing the amount of connectivity and the amount of exposure points. We've also had a lot of increase in the desire to have notifications remotely. We heard from, the others too, and how this is happening. So email notifications, wireless, et cetera, it's becoming more and more prominent. And I think, from a wireless perspective, and something we just heard about as well, is these end users are having more and more connected devices, potentially outside of the fire alarm system. But those of you may know the big Target breach a few years ago stemmed from a wireless thermostat that was hacked, and that gave them the entry point into their system. So All of these things are starting to emerge, as we've heard, and are growing the risk. You can see there's a quote from that Washington Post article today, or on Saturday, that really kind of indicated this, is this whole trend of exposure points and system connectivity is giving the elements of cybersecurity even more importance. We heard this from Roger as well, that the end customers are starting to demand more from their building systems, and certainly that's more that extends into the cybersecurity expectations. So, the federal government for sure is on its way in overall cybersecurity frameworks and requirements. That's extending down to the state level, and most states, have a pretty good, path, at least, or journey towards a cybersecurity program. Some are more mature than others, but every state's going to have some level of requirements. So any government work that anybody on the call is going to do is most likely going to run into some requirements around cybersecurity. But we're also seeing that obviously in the private enterprises, especially the large corporate entities that have to have cybersecurity programs in place, including, which we don't always talk about, is the data privacy and data protection. And if you're not familiar with things like GDPR, that is in Europe now, which is looking at how overall data from the systems and tools we use are handled, it's really important to start getting used to that and familiar with it. It's not just about protecting the data, but it's also about how it's being used, where it's being stored. And so as we're connecting our systems, we also have to be mindful of that. And needless to say, all these frameworks, requirements, specifications, and standards are starting to move into specifications. If you haven't seen that in a spec yet, I'm sure it's going to come up soon. And this mix of standards plus end user looking for more or higher, better return on investment on their systems, we're only going to see more of this. I think what that means for us in our industry is really that we need to be thinking about it in terms of these multiple layers needed for cybersecurity. So the first one we talked about before, the physical protection, continues to be a very vital step or vital layer in this process. So having physical locks, having forms of tamper indication and history logs, so you know who's accessing the system and when, very important. And then when we move beyond that into the broader fire alarm system, we have to start thinking about ways to have firewalls as part of the overall system. In code, and we'll talk about that in a minute, they're starting to give guidance on how these firewalls need to be implemented and what needs to be done from a performance perspective there. So some way to have that ability. So in the EST4, for example, we have a UL listed proxy firewall that handles all of our external communications and all of our node-to-node communications, helping to ensure that this notion of a network system is indeed cyber secure. And then going a step further around, the networking piece of this, and I spoke about this before with the way you are thinking about audio. So if you start to have this distributed audio network, and you can have now audio pre-recorded messages stored in each panel database around the network, you're removing that single point of failure and allowing for, even if there was an issue with one node, your survivability is still there from this voice notification. And then having the encryption or the ability to protect in between those nodes becomes really, really important. So some of you are familiar with this. You may know the term of a hashing algorithm. You may not have heard of a salted hash algorithm. So these are things where the hash is taking your data of some form and size and consolidating it down to a standard length, if you will, so that the communications between the panels are validated, that it's authenticated, and there's a kind of a checksum happening there. And then you can add a salt to it, which is basically a random value added to the password part of that hash to make it even more secure. And so having those capabilities between the nodes and the network give it that much more of a level of protection in this overall architecture. But that's only as good as the fire system. And as we've heard, there's this requirement and demand to have a broader, building management, smart building, if you will. And that comes with the enterprise level organizational systems security frameworks, right? So process, people, technology, and standards that are coming together to create an overall risk management framework that needs to be taken into consideration from a fire alarm, but then bridging out into the overall building solution. And then going forward, I think, what should we expect in the future? It's more of the same. It's even more mixed networks. It's even more connected devices. It's even more customer requirements, IT mandates, as we just heard. So all these things we've talked about so far is just going to become more and more prominent. And along with that, as Roger indicated, but I felt it's good to still talk about that. There are changes to the code that are helping to acknowledge this need and provide guidance. So in 2022, the next edition will start to show things like in Chapter 24, the reference that it needs, the risk analysis needs to be in accordance with Chapter 11. Chapter 11 starts to lay out the real basics of why cybersecurity is important to the local codes and standards and what type of things need to be done. And now it's pointing to Annex J. And as you know, what's in the annex is typically going to be moved into the code. So, we could likely expect in 2025 that the main body of code will include the details of Annex J and cybersecurity. And what that's starting to talk about is how the system should be designed, installed, and maintained in accordance with some cybersecurity standards. So today it talks about the ANSI IEC. NIST has a framework. UL's working on some codes. So, and there are obviously other standards as well. But there's going to be a need to have a reference in terms of how systems are designed, installed, and maintained to these cybersecurity frameworks. It'll also start talking about software changes and how those need to be reflected and whether the system needs to be tested based on those cybersecurity updates. So it's really important that code keeps up with these changes, and we're starting to see that be deployed. The last thing I wanted to leave with the group here is this is such a big topic, and there's a lot out there. So, what are the things that you as either a designer or an installer can do to be better prepared if you're not already there? And I think the first thing is probably obvious, but making sure that you're engaging as early as possible on system design. Obviously, this is important just into making sure the installation goes well or the design is working as intended. But now that we have this mixed network concept, these class N type situations, it's really important to understand what the network architecture is going to be laid out. If they're going to be running a more traditional IT network and want us to plug into it, how's that going to manifest itself in terms of the fire alarm system design? What kind of things do we need to be taking into consideration for that? So obviously, the earlier the better. Don't fear IT and start getting educated on IT and cyber. I think is the other piece of this is it's super important. There are a lot of resources out there, as I mentioned. You can certainly Google it, go to Wikipedia, but some of the better ones I think that we use and that I found out there are around just NIST in general. If you go to the NIST website, go to the information technology topic, you can see cybersecurity details, overviews, things like FIPS, if you've heard those terminologies, privacy standards, and a lot of other resources. I think the IEC cybersecurity has some great primers and resources there as well. And then even the government site, the CISA site, has some great resources. And one of the ones here I wanted to highlight, as many of the individuals on the call are part of a small or mid-sized business. And if you're not thinking about cybersecurity maybe on all your projects, you certainly should be thinking about it for your own business. And there's some great resources here that can help think about what kind of steps do you need, again, people, process, technology, and the standards to make sure that your own enterprise, your own business is secure. And again, given the ransomware attacks recently, it's not just big companies, it can be small companies too. So I think there's an important thing there just for your own company to focus on. And then, as I mentioned, I think it's really important to get familiar with where the codes are going. So if you go into NFPA and track down through the site to 72 in the next edition and pull up Annex J, get familiar with what they're talking about in the standards now, because it is coming and it's going to be more certain. So again, this is a very quick, high-level overview of cybersecurity and kind of where we've come from, where we are, and where we're going. I think it ties in with what everyone else said. Just want to emphasize the importance of making sure we have this piece really well articulated and understood as we move into this direction. So that's it for me, and I'll turn it back over to the team for the Q&A section.
Well, thank you, John. Great job, and great job kind of tying everything together and emphasizing the cyber aspects as well as the need for education there. So all great points. So I know we've run a little bit long here. I would like to still offer up an opportunity for some questions. So if our panelists, if you're still with us, if you could come back on video. And I think a number of these questions have been answered, but we received 3 in advance, and I think I can consolidate it down to 2. So what code requirements govern cloud connections to fire alarm systems? Does anyone want to kind of just, I know you've all sort of touched on that. Does anyone want to comment on that? All right, I guess I'll just throw out there that there were a number of relevant code sections that were brought up throughout, and staying in touch with NFPA and the updates is probably going to be our best way to stay on top of that. So we received another question, and I think, John, you just answered this one, but I'll throw it out there anyway. Is cybersecurity required for these cloud offerings? And I think that was probably your second to last slide there, right?
Yeah, for sure. I mean, I think there's a couple ways to look at it. I mean, there are certainly requirements based on, the government, municipality, and the jurisdiction that the building might be in. Just from if it's a federal or a government building, you're going to have requirements. The corporation may have specific requirements, but from a code perspective, that's what we're seeing showing up in the annex of 2022. So it is there in multiple levels. It's going to be more directly impactful. And I guess, Roger, certainly you're probably closer to the codes than any of us. If you have anything else to add there, feel free, but it's definitely coming.
Yeah, absolutely. There was a lot of work trying to put cybersecurity into the chapter, a new chapter in 72, and it didn't quite make it because some of the discussions came about is, well, my regular technician, who's a fantastic fire alarm technician, he doesn't know anything about cybersecurity. And then there were starting to be overbearing things for that person to do to ensure the right patches were installed, the right software was installed, and to test it all out. And because of all of that, as you said, John, it was thrown into the annex for the 2022 cycle. But yes, it's definitely coming. It's a little bit, as we always often are in the fire alarm world, lagging behind a little bit from the rest of the world.
Okay, great, thank you. And I just received a question to please comment on DACs and the future of DACs and that technology. Anyone care to take a stab at that?
Yeah,
I say DAC.
Go ahead, Roger. Then I can add if you don't.
So DACs are out there, digital alarm communicating transmitter. I was on chapter 26 for several cycles, and we tried as a committee to do away with DACs, actually, saying, look, phone lines are going away. We should sunset DACs. As of January 1st, pick a year, DACs can no longer be used. NFPA came back and told us you can't do that. It's not up to an NFPA committee to sunset a technology. It's up to the industry to do that. So instead, the committee then is forcing you probably not to want to use a DACT, where you have to send a signal once every 6 hours. Only one pathway can be done with a phone line. The second pathway's got to be done with something else. So that's why you started to see that progression happen. There's nothing I think you're going to see in the near future that's going to prohibit the use of DACs in 72. But as phone lines are going away, we as manufacturers are coming up with other ways to communicate, cellular, voice over IP, whatever is out there. But code will not force DACs to go away. It would be something manufacturers and technology will do.
Yeah, I was just going to add that similarly, the trend is overwhelming towards some other means. We hear it all the time and cellular is the predominant. So.
Okay, great. So Jim Monjo, would you like to add something?
Yeah, a question I have is with the development that's currently happening with NFPA 915, which is remote inspection, what is the future, or how are you looking at it, if you can share, with all this connected, IoT or emergent technologies? NF 915 is being developed right now. I'm just curious how that's impacting, or is it still too early to really put your arms around it? And just for everybody, NFPA 915 is the standard for remote inspection. Thank you.
Thanks, Jim.
Yeah, so I'll start it off. I'm on the Standards Council for NFPA, and when we looked at the 915 document, I'm not saying anything that's not public knowledge. It first came about with this remote inspection was, I have a building, it's being framed out. I'm the AHJ. It's a 3-hour drive to get there. Couldn't I allow a guy to fly a drone, take pictures, take video, send it back to me? I reviewed it and said, yes, your pre-approval to go forward in this part of the project is approved. Your structural, sign off is approved. That's where it kind of started. And I'm seeing it and we kind of expected it at NFPA to morph into other things. But that's where the whole remote inspection concept came from. I believe, this is just me speaking for me, I believe one day we are going to see in the code that the ability for me to be in a office hundreds of miles away and do some type of an inspection of a life safety system will be coming. Just with the way that I'm able to gather the data, send the information out, collect it, have it reviewed by a person that's knowledgeable in what they're seeing. Kind of like OnStar for your car. You drive out once a month and you get a report. And here's the basics: tire pressure, fuel levels, when it's time for your next service. And that's where I was talking about in my presentation. I think we're not too far off where it's going to be, I'm sending you a report. Hey, you got 3 months left until your annual inspection. You have 2 smoke detectors that are almost dirty. Part of your system did an automated test. Here were the devices that failed. A technician is scheduled to arrive in 3 hours. That's where we're going. I think we're all kind of in that same boat.
Okay, let's see.
I'll just add to that. The sooner the kind of code, I mean, I think the code's kind of behind the technology to a degree, and the sooner that we kind of influence these standards to actually move to where building owners want us to be. And I'll just add to what Roger was talking about as well. I think there's some degree of where certain customers might want to kind of provide certain services, and you talk about competency when you're doing this, but the big juncture where are kind of installation experts and people who know what they're doing is around the liability question. I'm not sure. That's the one kind of little bit in the ether, I'd say, that kind of makes that challenging, because ultimately that liability wants to be removed from a building owner to somebody who's professional and knows what that's about. But to Roger's point, I think there are bits that we should be able to kind of amend the process for to enable us to do smart things remotely, so that when we're on site, we're a lot more efficient, a lot more effective, and a lot less cumbersome and imposing on people's buildings, because that ain't good either.
Well, and then I think this whole COVID pandemic thing is going to cause 915 to morph more than we all thought it was going to. Where I have facilities, I have hospital healthcares that said, I don't want your people coming into my facility. I can take care of my own stuff. Yeah, but you have to have it inspected. Well, I think you're going to start to see a compromise of what can be done remotely with internal, external people, so that if there ever is another pandemic.
I was talking to a customer who had a whole chain of assisted living homes, and it's a balance of risk, and they did the responsible thing and said the balance of risk of sending a technician to that site right at the height of COVID-19 was greater than the risk of anything being wrong with that life safety system. So they didn't send anybody in, and it was the right thing to do. It was the right thing to do. But it's always a balance. So how do you kind of get beyond that? Because actually, a lot of consultant engineers and a lot of people, when they're looking at buildings, God forbid COVID-20 pops up, but they're genuinely looking at this stuff to kind of ensure that they're kind of future-proofing their building for exactly those reasons. We're a lot more aware of it now, and that's going to take some time for people to kind of get back into the new normal. But once you're bitten by this, that's what shifts codes.
Exactly.
I think we just received one more question through the chat about BDA systems, emergency communication systems, and whether there's some cloud impact to those in the future.
Yeah, if I could chime in, I mean, there is definitely a cloud component. So one of the requirements in some jurisdictions is that you have to be able to turn it off remotely, and not surprisingly, there's likely use of the cloud. There's also use of the cloud for for configuration information, drawings, the layout of the building. There are cloud tools associated with where you need to position the different antennas, et cetera. So cloud's going to play a big role. And then just in a broader sense, talking about BDA and ERCES, we see that continuing to grow. And actually, we're looking forward to even further code refinement, because what I have seen some communication about is people who don't understand it get nervous about interference caused by multiple BDA amplifiers, and so they'd rather just turn them off, which is the absolute worst answer. I think the better answer is just learn how to properly use it, and I think the codes will help with refining that so that they are properly installed and properly used.
Okay. Well, great. I think with that, we're going to wrap it up. A big thank you to all of our presenters. Fantastic job. It was very educational for me anyway, and I'm sure for all of our guests as well. I love the content. You guys all touched on various topics and kind of wove them together in a way that was very helpful. So thank you all, and thanks for joining us today.
Thank you.
Thank you.
Thank you.
Bye-bye.
Thanks very much. Cheers. Bye.